We are working on section 9.4, which is solving polynomial equations in factored form. One of the first things you have to know is a zero product property. And what it states is, if A times B is equal to 0, then A equals 0 or B equals 0. Think about this for a moment. If you multiply two numbers together and you get 0 as an answer, doesn't it make sense that one of those two numbers you multiply together has to be equal to 0? We're going to solve an equation using that property to help us. This equation is already in factored form for us. That might help us in looking at this problem. It's kind of like half done already in factored form. Once it's in factored form, we will set it up so that you have this binomial. This is a binomial factor, and the x minus 1 is also a binomial factor. Each of those factors multiplied together equals 0. We'll use that zero product property. We say x minus 5 equals 0, or x minus 1 has to equal 0. One of those two binomials has to be equal to 0. Well, you solve the equation, and when you solve the equation, you find out that x is equal to a positive 5. For those of you who may have forgotten, you're adding 5 to both sides in order to get x by itself. Here we're adding 1 to both sides in order to get x by itself. We'll have x equal to 1. There are two answers to this problem. Let's look back and check to see if these answers are correct. Putting 5 in for x, we have 5 minus 5, which is 0, and 5 minus 1, which is 4. That gives us 0 times 4 equals 0. True statement. Now put the 1 in for x. 1 minus 5 is a negative 4. 1 minus 1 is 0. Negative 4 times 0 also gives us 0. Both are true statements. Both are answers to the equation. Again, this equation was kind of like in the middle of the equation. It was already in factored form for us, and we set each of the factors equal to 0. You might need to factor polynomials before you start solving. And one of the things to look at is to check for the GCF. In other words, the greatest common factor. Let's find the greatest common factor in this problem. When you look for the common factor, you are looking at the numbers. You have 14 and 35. Think about what number will divide into both of them. What number is a factor of both 14 and 35? And we want the biggest one. 7 is the largest number that goes into both of them. So now you should be thinking about dividing both of these by 7. 14 divided by 7 is 2, with the m still there. 35 divided by 7 is 5, with the n still there. And this is in factored form. How can I check to see if I'm right? You could distribute that 7 back in. 7 times 2m, does that give you the 14m? It should. 7 times 5n, does that give you the 35n? It should. What factoring is doing here is undoing the distributing that you've learned how to do. We're finding out what number was distributed inside. So this is our factorization for 14m plus 35n. Let's do another factoring. This time, when you look at the problem, not only is there a number that they both have in common, but there's also a variable that they both have in common. Look between 14 and 21, what number they have in common. The number should be a 7. And they also have at least one y to the first power, in common. If you look, they don't have a y to the second power. Both of them don't have that. You look at what's the smallest exponent. So we're looking at y being our common variable between the two. And then again, you are thinking about dividing by that common factor that you took out. And when you do so, you have 14 divided by 7 is 2. Y squared divided by y is y. 21 divided by 7 is a positive 3. And y divided by y cancels out. So we're left with 2y plus 3 inside the parentheses. This is the factorization for the problem. 7y times 2y plus 3. You can check 7y times 2y gives you 14y squared. 7y times 3 gives you 21y. Let's factor one more here where we are taking out the GCF first. Look at the two numbers, 4 and 24. Think about what the number is that's going to come out. It should be a 4. Now look at the variables. They each have an x. In fact, they each have x to the second. Wow, look at that. They even have x to the third in common. When you look at these, this is like looking at x times x times x times x. There's 4 of them, and this one has 3. They both have an x to the third in common. That's what we're going to put on the outside. Then we're going to do our mental division. We're dividing mentally by 4x to the third power. 4 divided by 4 is 1. X to the fourth divided by x to the third is just plain old x. We don't have to put the 1 in front of that x. And then 24 divided by 4 is a positive 6. And x to the third divided by x to the third is 1. So we are done with our binomial there. Here we have the factorization for this polynomial that we were working on. Let's solve the equation by factoring then. We take the first part where we were solving equations and the second part where we're factoring, and now we're putting it together. So we start out taking the GCF, and the GCF, when you look at a squared and 5a, they have no numbers in common besides a 1. We don't need to write that on the outside. But they do have an a in common. And so when you think about dividing by a on both of these so that you can factor it out, a squared divided by a is a. 5a divided by a is positive 5. And this is equal to 0. Now we have two items being multiplied together equals 0. One of them must be equal to 0. So we start out with our monomial factor, and we're going to set that monomial factor equal to 0. Then we also have a binomial factor, and we'll set that binomial factor equal to 0. On the a equals 0, there's nothing else we can do to it to solve it. But on the a plus 5 equals 0, we can solve, and that becomes a equals a negative 5. We now have two answers for our problem. You can even check them. Put 0 in for a. 0 squared is 0. 5 times 0 is 0. 0 plus 0 equals 0. Put in negative 5. Negative 5 squared is 25. 5 times negative 5 is a negative 25. Positive 25 plus a negative 25 equals 0. Both of those answers work. They are the solutions to the problem. Let's do another one here where you're taking out the common factor. The common factor between 3 and 9 is 3. The common variable between the two is x. When we divide, we are thinking of dividing by 3x on both of these. 3x squared divided by 3x leaves us with an x. Negative 9x divided by 3x leaves us with a negative 3. Please notice that's a negative number because we have a negative divided by a positive. Then we will set each of our factors. The first is a monomial factor, 3x equals 0. Set them each equal to 0. Here's our binomial factor. When you are dividing here, dividing by 3, I hope you remember that 0 divided by any non-zero number is always equal to 0. Here we are adding 3 to both sides, and x is going to be equal to positive 3. These are our two answers for this problem. It's a quadratic equation, two answers for x. What happens when one term's on one side and one term's on the other? Well, you need to bring this term over to the other side. What you want to do is keep your leading coefficient positive if you can. It just makes your life easier. So make it 4y squared minus 14y equal to 0. Factor out your common factors. In this case, our common factor between 4 and 14 is 2, as well as they have a common variable is y. Now when you look at dividing by 2y on each of these, you have 4 divided by 2 is 2, y squared divided by y is y. Negative 14 divided by 2 leaves you with a negative 7, and y divided by y is 1, so we are done with that part of the factoring. Once you've factored, again, we're going to use that zero product property. We'll set our monomial factor equal to 0. We'll set our binomial factor equal to 0. When we divide by 2 on both sides of this equation, as we got before, we'll find out that y is 0. And on this one, we are going to add 7 to both sides first. Be careful about your order of operations here. 2y is equal to a positive 7, and then we want to divide by 2 on both sides so that we find out y is equal to 7 over 2, or you could have y is equal to 3.5, or you can have y is equal to 3.5. I am just fine with that lovely improper fraction as long as it's in lowest terms. Please? Thank you.